Hello and welcome to the Edupedia world. Well, in this tutorial, we'll study about streams or file IO in Java. So let's begin. Well, this is a big tutorial and probably we'll cover it in parts. So let's begin with the first part. So the objective of this tutorial is become familiar with the concept of IO stream. Understand the difference between binary files and text files. Learn how to save data in a file. Learn how to read data from a file. So this is we want to do as per this tutorial. So let's begin with the first. Okay. So these are the topics of the that we cover over here. So first we can see overview of streams and file IO. We'll see what all streams and file IO classes are there in Java. Then we'll study about text file IO. Then using the file class, we'll see different methods of that and how can we use file class. Then we'll see basic binary file IO. After that, we'll see object IO with object streams. Then we'll see graphic supplement. Well, this is an optional topic, so we decide whether we'll be covering over here or not according to the time and probably the requirement. So our first objective is learn how to use classes, object output stream and object input stream to read and write classes object with binary files. So this is another one of you can say input to know about these classes object output stream and object input stream and to see how to read and write class object with the binary files. Fine. So now we have like IO overview. So we'll start with the IO overview. So what do you mean by IO? Well, IO means input and output. For input we just say I and for output we just say O. So in this context it is the input to output from programs. So it can be like from one program to another. Okay. Now input can be from keyboard or a file and output can be to display on a screen or maybe write in a file. Okay. The advantage of file IO is that it provides a permanent copy. That means you will have a permanent copy of whatever you have written. Now the output from one program can be input to another program. That can again be one of you can say advantage. Third one is input can be automated rather than entered manually. Note, since the section on text file IO and binary file IO have similar information, sides are included. So now let's see what are streams. Well, a stream is an object that either delivers data to its destination, that can be screen, file, etc., or it takes data from the source, that can be keyboard, file, etc. It acts as a buffer between data source and destination. Fine. So basically you can say it's kind of a carrier of your data. So it's actually an object which delivers. Okay. So it is a buffer between the data source and destination. Then what's input stream? Well, a stream that provides input to a program. Okay. So anyone that is providing input to a program, for that program, that will become an input stream. So obviously stream is with respect to which object we are talking. For example, here if we are talking about a particular program, then for this particular program, system.in can be an input stream as it provides input to this program. Fine. Similarly, output stream is a stream that accepts output from program. So for example, system.out is an output stream. So it is used to accept output from a program. For example, in order to print something, in order to accept the output, we do use system.out. Okay. And in order to take users input, we do use system.in. Now, a stream connects a program to an IO object. Now system.out connects a program to screen because we get the output in console. And system.in connects a program to keyboard. That is, whatever we type from keyboard is taken as an input for that program. Okay. Now binary versus text files. All data in programs are ultimately zeros and ones. Each digit can have one of the two values, hence binary. Okay, so you can say like what's the difference between binary and text file? First of all, binary is having everything in form of zeros and ones. So each digit can only two values. One is 0 and other is 1. So therefore it's called binary. Bit is one binary digit and byte is a group of 8 bits. So a byte can contain 8 bits, whereas a bit can have a single unit of binary. Okay. Now what are text files? The bits represented in a printable character. So basically all the information via web or via any communication travels in a form of bits that we know, and bits do form bytes. Now if these bits are represented in a printable characters, then it is called as text files. So note that we are saying printable. We are not saying human readable or readable by me or you. It has to be printable. If it is printable, then it's a text file. 1 byte per character for ASCII, the most common code. So ASCII is the most common code that we use, in that for 1 byte we have one ASCII character. Okay. For example, Java source files are the text files. So if any file created with a text editor, it will also be a text file. Okay. Now what are binary files? Well, the bit represent the other types of encoded information such as executable instruction or numeric data. These files are easily read by computer but not human. So when we talk about binary files, so everything is in a form of zeros and ones. So definitely for humans it's a bit difficult because you have to do that calculation in your mind, but for computer it's very simple to read that file. Okay. So these are not printable files. I mean, it's not that you cannot print zeros and ones, but these binary files are with that kind of extension that cannot be printed. Okay. Actually, you can print them, but they'll be like, intelligible. I mean, you cannot read them. Then printable actually, when we say printable, it actually means that, it can be printed by humans and could be understood by them at least. Okay, so that's why binary files are really difficult for humans to understand. So that was about the binary files. Now let's move forward to Java text versus binary files. So now again in Java, how does they differ? So we have talked in a general terms. Now what about in Java? Well, text files are more readable by humans, and binary files are more efficient because computer can read them. Computer reads and write binary files more easily than a text file because for it it's actually a computer understandable language. Now Java binary files are portable. So definitely, I mean the size is less, you can easily port them. Okay. They can be used by Java on a different machine because it's like machine understandable, and if you just try to run it on any machine, that machine would be able to understand that because it's a binary file. Now reading and writing binary file is normally done by a program. The text files are used only to communicate with humans. So it might be possible that your program might give you a text file, but internally it does calculate the binary file also. So you see, text files are source files and binary files are executable files, that is created by compiling source files. Okay. Then Java text files occasionally input files and occasionally output files. So in that we kind of input files and output files. And when we talk about binary files, so the program actually usually input files and output. So that's usually, I mean the binary file usually does get formed, but text file depending upon user requirement is get formed by Java programs. Okay. Okay, so this is an example of binary versus text. You can see we are having a number 127, which is a decimal number. So if you see, it is having kind of 3 bytes. One is 1, 2 and 7. Okay, and the sky for this is something like 49, 50, and 51, and it can also be represented in a sky octal as well as a sky binary like this. Now, what will be the binary file for this? So let's take an example of binary file. So when we say 1 byte, so 1 byte will be represented as this character. You see, like, we are having number of ones and zero. Then 2 bytes, which is also represented as short because short do contain 2 bytes, will be represented as this. So 8 characters over here and 8 characters over here will make 2 bytes. Integer, which we represent as 4 bytes. Integer are usually ever stored in 4 bytes. Thus, they take a space of 32 bits. Okay, because 8 into 4 gives you 32. So over here you see like the same number is represented in 4 bits. So it is appended by zeros and then the final number. So this is how the binary files store the values in forms of zeros and ones. Now, this is an example of a text file. So the file name you can see is having a file HOD So, and this is a path. I mean, it's just a random path given and how these files looks and how it contains the data. So this is how it is containing a data. So you can see it's a human readable text that it contains. You are definitely able to understand and read that text what it is written. Fine. Now this is an example of a binary file which is can be a .class file. So this is something like this. Although you can see the same thing is written in a text, but over here it is actually written in binary. So as a text what it will write is 127 smiley and faces. Okay. But if you go through this, so it is written something like that, some other characters you cannot understand where is 127 from it coming and from where smiley is coming, etc. etc. So it's difficult to understand. Now text file IO. So we have seen what is text file, what is binary file. Now let's see what is text file input output. Fine. The important classes for text file output that is to the file are print writer or file output stream or also known as file writer. Okay, so these are the important classes used for writing text files output, that is print writer, file writer, and file output stream. And what are the important classes for text file input, that is from the file, reading from the file, is buffer reader and file reader. So obviously there are many more, but these are significant top classes. Okay. Now, file output stream and file reader take file names as an argument. So you have to provide the file name which you want to read or write. Okay. But when we talk about print writer or buffer reader, they provide useful method for easier writing and reading. Okay, so they do have some additional method which will give you a better way of writing and reading. Usually, we need combination of two classes because it's always, we are reading from a file and writing to other files. So usually we write program like that. But obviously there is no compulsion to that. So let's see some of Java code over here. So you see we have to import Java IO package for using these files because these files are present in Java IO package. Fine. Now what is buffering? Well, you usually have heard this term, yeah, video is buffering. So what is buffering and what is not buffering? Well, when we say not buffer, that means each byte is read or written from or to disk as soon as possible. That means there is very little delay for each byte. So it's like as soon as a byte is read, at that moment only it's written to another resource. Okay. So the disk operation per byte and the higher overhead because you open a file, read a byte, write a byte to another file, then again from a file pick a byte, read it, and then write it to another file. Okay. So this is not buffered. So this is like real time. We have to do that each time for each byte. And what is buffered? That means reading and writing in chunks. So that means like you read first 10 bytes and then write those 10 bytes. Then you continuously keep on reading those bytes till you read 10 bytes and then you continuously writing those bytes. So you are doing the work in chunk. So this actually gives some delay for some bytes because it has to firstly read those 10 bytes. So before start writing, there will be a slight delay. We assume like there's a 16-byte buffer. So that means reading access the first 4 bytes need to wait for all 16 bytes. So that means although you want to start reading the first 4, but you have to wait for all the 16 bytes to be read. So once the 16 bytes are read, then you have to write. So that means you have to save the first 4, need to wait for all 16 bytes before writing from memory to disk. Okay. So over here there is low overhead and as compared to disk operation, because again and again you do not have to read and write from the disk. So the number of times that you have to read and write from the disk actually decreases, because earlier you were reading or writing 100 bytes, so there were 100 operations. But now if you are doing it in a terms of chunks of 10 bytes, then you are doing it 10 times. So you see the overhead actually decreases if you form a buffering, if you do a buffering, if you read it in a chunk. Now every file has two names. The stream name used by Java, which is like output stream in the example, and the name used by operating system, which is like output.text in the example. So when we say two names, that means like inside your Java program, there is a thing which we call as output stream, which will be a stream name, and then there will be actual file name which you want to read, that will be for your operating system. Okay. Now let's see text file output. Now let's see about opening a text file. Now to open a text file for output, connect a text file to a stream for writing. Okay. So there's a print writer output stream equals to new print writer, and then in a parameter you have to pass new file output stream, and then you find the file name. So file name over here is out.text. That's why I've given out.text over here inside a file output stream. So this will actually create a file output stream object, and after that there is a print writer object that you are writing to the file. So you see print writer object actually takes a file output stream object. Fine. Similar to the long way, file output stream s is equal to new file output stream, which just you can write it in another way, where you are firstly creating a file output stream object which is taking out.text, and then you are creating print writer object which is you have created by passing the file output stream object. So this is like a longer way of writing the same thing. Fine. Now what is our final goal? Final goal is to create print writer object which actually uses file output stream to open the text file. Okay. So file output stream actually connects print writer with the text file. So I hope you got the concept of file output stream and print writer. So this is a diagrammatical representation of same. So you see there's a memory. From the memory we are like from a Java program, we have created a print writer object which is using file output stream object, and file output stream object is finally accessing the smiley.txt file for print writer to write onto it. Okay. So this is how it is done, and this is how we have written it in a code. Now methods for print writer. Similar to methods for system.out, like we have println method, we do also have methods for print writer and output stream. So you see, like over here, we are having a method output stream.println, and what we are doing, we are printing count and line. So similar to the println method we use with system or out, we can use it with output stream. Okay. So other methods that are there for print writer are print. Okay, so with the print writer object, you can also use the print method. Then there's a format method. Then we have flush method, and then we have close method. We look at each of them in detail as well, but just to tell you that just like print is to print, format is to change, make any formatting. Flush is to, after doing the writing, you have to clean up your buffered output. So that's why you use flush. And close is another important function, because you have to close your stream every time you have finished your work. Otherwise, it will keep on accessing your resource or file even after your work is done and might create problems. Now let's do a text file output demo. So in this demo, this is part 1 of demo, and over here you can see that we are actually trying to just open a file. Okay, and how to do that, let's actually see in this program. So you see we are having a main method. Definitely it will be in a class. We haven't written a class. Inside the main method we have created a print writer object. So the object that we have created for print writer is output stream. Currently we are initiating it as null. Then we are having a try block. So the try block is added because output stream would not be accessible to rest of the method if we declare it inside a try block. That's why we need to declare the print writer object outside the try block so that it can be accessible outside the try block also, like in catch or after catch also. If we want to close it, then it should be accessible. So that's why we have declared it outside the try block. And why do we need try block? Well, we need try and catch because whenever we just call this method, create object of print writer, so it could give us a checked exception. So to handle a checked exception, we have to write a try block. What kind of checked exception it gives? That is file not found, because it could be possible that the file that you are trying to access is actually not found. So then you see that inside the try block, what we are doing is we are having output stream equals to new print writer, and then we are doing new file output stream and passing out.text to it. So our out.text is our file name, and file output stream is able to access the out.text, and thus it is acting as a buffer and providing that file output stream object which it has created by accessing out.text to print writer. Now print writer can use it for different purpose. We have formed our object of output stream to do some writing, etc. What if out.text is not found? Then exception is thrown and it is cached in the catch block, which is file not found exception, where we can write our own predefined message. So over here we are writing error opening the file out.text, and we are also printing the exception trace. Okay, and then we are exiting by using system.exit 0. Okay, so this is the way we can actually open our file. Fine, guys. Now part 2. In part 2, let's try to write to the file. So when we say writing to the file, so you can see we are having system.out.println as our first line. We are saying enter 3 lines of text. Then we have declared a variable line equals to null, then count, and then we are using for loop to count the number of lines we are actually writing. Inside the for loop, we are taking, there's a keyboard object that it's using. So as of now, just ignore like from where this keyboard object has been created. Just assume that, you are hard coding some line. Let's, ignore this line keyboard dot next line. Rather assume it's like line equals to whatever you want to write, your own text, hard coded text. So that is the text you want to write, and then to write it, you can use that output stream object. It is an object of print writer you have created, and call the method println and pass whatever you want to actually print. So we are actually writing to the file. So println is actually writing to the file. So once you have written all the 3 lines, then it's obviously really important to close your stream, because if you don't do that, then it will keep on accessing the resource, and if some other resource tries to open it, it won't be able to do that because your resource is having lock to it. So that's why it's important to free the file. So you should do output stream dot close. Okay, so this is what we are doing. So you see println method is used with 2 different streams, that is output stream and system.out. So we have already used it many times with system.out using like system.out.println, but this time we are using it with the output stream, which is a print writer object. Fine. Okay, so now we are having some more concepts about overwriting a file and so and so. But I think as of now we should take a pause, because otherwise our video will become too long. And let's continue the remaining part in the next video. Okay guys, so thank you very much for attending this tutorial. Now let's meet in the next video. Thank you.